All right. So this first week, we're just going to be covering some of the highlights of what Palo Alto offers, going through their portfolio, talking about what is a next generation firewall architecture, and then what kind of firewall offerings they put in there as well. Let's see here. So the big deal with Palo Alto's approach to cybersecurity is they want to give you complete visibility, reduce that attack surface, and give you some known threats. This section, this last half here, where they're preventing, you guys can't see anything up there. Stand by. I will pause again. Uh, Pause. Okay, so this last half here I was talking about was this prevent known threats and prevent unknown threats. That's really what helps Palo Alto set itself apart from something like OpenSense or PFSense, where they do have the ability to do some of those features. They're usually a third-party product baked in. Things like PFSense and those are starting to add those features in, or you can get subscriptions to that. Most other open firewalls, you have to subscribe to some third-party service to put that in. Palo Alto has that and it's baked in. And because they're using all of the firewalls that are out there to help send feedback of things that they find as threats, and because it's in a lot of different facilities, they tend to have more or better threat prevention in some cases than many of the other vendors out there. It's just based on sheer quantity is one of the main reasons why. But they spend a lot of time on their threat prevention and detecting threats, both known and unknown. So in a next generation firewall, this is kind of the foundation for Palo Alto. In the old days, when we talked about firewalls and such, it was really based on the port. And then at one point, we got into things like application layer testing so we could actually see what was going across the port. So for example, most of you guys at your home, right, you allow port 80 through, right? And what's port 80?
Web.
Right? So you have port 80 traffic, you're allowing that through, but we can send anything through port 80 as long as it's listening on port 80, right? So I can set up SSH, which is normally running on 22. Thank you. I thought this was going to be a really long semester for a second. All right. So port 22, we could actually set that up to run on port 80 and it would traffic across port 80. The firewall doesn't know and doesn't care what is actually going across the port. It just opens up the ports. In next generation firewalls like the Palo Altos and some of the others, it's actually inspecting the traffic that's going across there, making sure that it matches whatever you're trying to allow it to be. So you don't have the college students that are trying to fool campus and no, I'm not, doing the stuff I'm not supposed to in my dorms. Why are you smiling there? Yeah, that's what I thought. Where you're trying to pass off things like BitTorrent and other stuff on known ports, and then it doesn't look like it's a problem because you can get through the firewall, right? Palo Alto and those would actually inspect that traffic and go, hey, you're trying to mask BitTorrent over port 80. That isn't going to work. We're going to actually end up blocking that kind of traffic. And so it can get really, really detailed into what it's doing through its ports. It can detect what kind of applications going through there. It can detect the traffic. It can detect whether it's encrypted. And even if it is encrypted, we can actually decrypt the traffic going on the fly. There's all sorts of stuff it can do over the top. They have two different generations or two different series that they tend to work with, which is the VM series. Those are a virtualized form factor of the Palo Alto firewall. Typically, this would run on like a VMware infrastructure, or in this case, it could be a Proxmox type infrastructure, anything that's based on the KVM type style. They usually provide both images if you choose to run it in that fashion. And there's pros and cons to that, right? So anybody that's played with virtual machines knows that you can spin one up, you can tear it down, you can clone it, you can do backups. But the problem with a lot of that is performance. Sometimes for performance to work great on those, you have to pass through hardware. And if you pass through physical hardware like NIC cards, et cetera, in order for that to work great, you've now lost the flexibility of the virtualized side. So a couple different reasons you might want to go both ways. The CN series is going to be the container native version of those, which has a little bit of machine language powered. And that's specifically designed for the Kubernetes type of environments. You also have the cloud delivered security appliances. Those are ones with enhanced threat prevention services. And that first one up there is typically going to be the physical pieces of hardware, right? It's the stuff we slap in a rack, has a bunch of ports on it, and they come in various sizes going through there. And we'll talk about the different models. The last one is going to be Panorama. That is a centralized management and logging system. So if you are a business and you have multiple of these Palo Alto firewalls spread all over the the state or country, or you have multiple locations, it gives you a place to centralize and bring everything into one. And of course, it's an extra paid for service that you pay for there. All right. So in the Palo Alto networks, they use what's called a single pass architecture. In that, the operations are happening on a per packet basis, where it's classifying the traffic using the app ID technology. It's going to use user and group mapping. You can also do content scanning for threats, URLs, confidential information. The firewall knows whether or not you typed in a social security address and will actually block the traffic. Like, there's a lot of intelligence built into these type of firewalls. Both good and bad, right? Because now you just added exponential type of processing going through there. So for example, most of you guys with your port-based firewalls, you can actually get some pretty good throughput there, right? And a lot of those firewalls, the little cheap, simple ones you have at your home, kind of cap out before you ever reach the gig service that you may purchase from Nextech or Eagle or Vive or whoever's running internet service in your area. And a lot of that's because those little devices just can't crunch those packets. Now, when it comes to just doing pure NAT, most of them can reach that gig throughput. But the moment you start doing packet filtering or you start doing anything else, that throughput drops dramatically. And you're going to see that even in these Palo Altos, that it may have a 1 gig port on the front of it. That doesn't mean it can process at 1 gig. That just means that the port speed is 1 gig. When you actually send it through the firewall and it has to do all this analysis going through, you may only end up with 500 mega throughput or 250 mega throughput. It's not necessarily a license. It's just the amount of hardware and the amount of processing speed that's built into it to handle it. So when traffic comes in down there at the bottom, you're going to see it work its way up through. First, it checks in the user ID side, app ID, then up through content ID, and then it starts checking against your policies that you have in there as well. Because of that, you typically have 2 different planes when you are operating within a firewall. So we have what's called the control plane. This is purely for the management, configuration, logging, and reporting. You have a CPU, RAM, a solid state disk, and you typically have a management interface or a console port. Those of you guys that have been coming from the Cisco world, when we have all that content, that is all in-band management, at least what you guys learn within the Cisco curriculum here. You do have the console port or the serial that would be considered out-of-band management, but you can't actually hit the IP address of it and manage it out of band, so to speak, right? You guys can assign a VLAN IP address or a management IP address on the switch, but it's on the same network and getting the same traffic as the traffic that's going through it. In this case, it actually has a port on it. So for example, like this is a switch. You have your console port on the back. You guys would have a port that's dedicated purely for management purposes. And that could be on the same subnet that you're protecting. It could be an entirely different subnet in general. You're also going to go to this port in order to manage the firewall. You could open up ports on these, which you guys are used to doing at your home firewalls, where you just jump on the wireless or you jump plugged in and you go to 192.168.1.1 and pull up the firewall, right? In this case, you would have to be directly connected to that port, or it would actually take a cable from there back into your switch in order to access that locally. And so in the lab environment, when we cut through that next week, you're going to see that there's going to be 2 connections up to the firewall, even though it's virtual. One will be going to the management port. The other one will actually be handling inside traffic. The other reason it does that is it allows it to go out to the internet and do connections through the management port outside of what you're actually passively monitoring and filtering and doing everything on this side, right? So you can think of it, and it's what it's called, is an out-of-band management port that can handle all the firewalls, it can handle all the updates, it can handle everything in between. Also, if you were to kill your network or apply a policy that pretty much shut down your network, bad policy, right? You could still manage this device from the management console, or in this case, the management interface, right? They do have console ports, serial ports. You guys are used to hitting those on the Cisco world. We typically don't use that in the Palo Alto world. It has it. It has things like SSH access as well. That's very rarely used. As opposed to the Cisco devices that you guys are used to in the networking stuff, the Palo Alto actually has more power in the UI than it does at the command line. Now that's kind of changed. That's speaking back to like PAN 8, PAN 7, those days. And that's a version number of the operating system. Today we're at PAN 11. And now those are pretty much on par with one another. These also have a really good API and an XML type interface, REST API that you can interact with. So those of you that went through, like, say, my 601 advanced Python course, you guys would be able to read the API and be able to interact and configure this thing through Python if you chose to do so, or whatever REST API that you wanted to play with. It's pretty common, and it works really, really well from that side. But that is a control plane. Again, it has nothing to do with the data plane that goes through. And so the data plane, this is where we're actually looking for signature matching. For example, known exploits, viruses, spyware, credit card numbers, social security numbers. If it has a pattern recognition and it matches it, we can actually block based on that. Right? We can also do other processing for app identification, user identification. URL match means that we have a blacklist of URLs we don't want them going to, or the opposite, we have a white list that we allow them to. Policy matching, SSL and IPsec encryption and decompression, and we can enforce policies based at that. And then you have your standard networking processing as well. This is your typical flow control, MAC address lookup, routing, QoS, and your typical NAT service that most of your firewalls are providing. All right. So you can use it very, very simply, or you can make this thing really get into the nitty gritty of the packets that are going through it. In the old days, we called it deep packet inspection, and it was a big concern. That's where you actually had the terms net neutrality come in. And now you've heard that again because they've actually revoked net neutrality. This was the reason why, is because the ISPs can actually run this. Think, for lack of better words, think China. They literally monitor every outbound internet access. You could do that same thing with this and shut it down and kill people's internet access. At a company or at your home, it makes sense as to why you want that, right? But when the general public wants access to the internet, you expect it to be free and open and the ISP not blocking it. That all changed again. The ISPs can do whatever they want in order to provide the best service. So if you want access to the full internet unblocked, maybe you pay $100 extra a month. If you want to be getting the normal service, which is what everybody gets, except for the stuff they don't want you going to, for example, they may throttle down your Netflix account so that you can go buy their TV service instead, right? It's not cool, but that's the way it works now when they revoke the net neutrality clause. Right. How do they do that? Equipment like this. They'd be able to filter and monitor and recognize what you're pushing through it. So in a zero trust architecture, we never trust anything, and we always have to verify the traffic that goes through there. So we inspect all perimeter traffic, and including inbound and outbound traffic. We also inspect any internal traffic going on. So by default, everything is zone-based as we work through these firewalls, and you'll see what zones are going to look like. But anything that goes outbound, we inspect. If it comes back inbound, we inspect it. And we also do east-west, which means anything on our network. If I am this laptop trying to communicate with that PC, I will also inspect that traffic, not just north-south going out through the internet. Does everybody get the directions and what that really means in networking? North-south means you're going out to the internet, coming back from the internet, typically. East-west means you're on the same local LAN and the traffic that goes across it. Typically, we trust things that are on the same zones, like this PC and that laptop, or what, vice versa. But we can actually inspect that traffic and go, hey, that looks like a virus. We're shutting it down. Okay. Last is those firewall offerings. So like we talked about, they have a very flexible architecture. You can do anything from the hardware series, which looks like one of these switches and a little 1U. You can have like their little 220 device. It sits about 6 inches wide and about yay big and about that deep. I hate it. It's so slow. So very, very slow. In the bigger chassis, they've got ones that, if you guys are familiar with like Cisco 6500s, they would literally stand this tall, looks like a giant chunk of metal or a boat anchor. That is what they're using for the high-end firewalls. So Fort Hayes here also uses a similar chassis to this on a Palo Alto. So it is a big firewall chassis that's in there. And at some point, I'll take you guys over to the data center and we can actually see what a physical one looks like since we have access to one. From the software VM series, again, you have the VM series, which is for virtualization. You have the CN series, which is for container virtualization. Containers is often associated with what? You guys remember the technology we mentioned earlier?
Kubernetes.
Kubernetes, right? So just think the CN series is only going to be usable on Kubernetes. That's really what it's meant for. Where the VM series is going to work on VMware, KVM, Proxmox, that kind of thing. They're going to have virtual machines for that. That is what you're going to use in this class. You guys are going to use what's called a VM50 device, and that VM50 allows you to have everything you would get on physical hardware. It just has it virtualized so that you can run it on a virtualized environment. You guys can again install that on your laptop if you have VMware Workstation, etc., which Workstation is free now, so you guys can all go get that without any licensing. You can actually deploy one of these on there. I can get you a license key to use, etc. It's a 1-year license key, and it actually has the full gamut of threat prevention, detection, the whole 9 yards. It's like $1,500 worth of software or more that you guys would get in access to play with that thing. And then last is the cloud service or the Prisma access. This is really for the cloud delivered portion of this. This is what you would get on Amazon or a couple of the other online providers that they have access to on there. All right. So as you look through these, and you'll notice that 220 I was talking about is dead and gone. They pretty much only work at the 400s now. So at the small portion, you have the 400 series, the 410. Now you have the 800s, and the 800 we actually have in a rack over in the data center. I can show you what one of those look like. Then you have the 3400 series, the 5400 series, up to the 4450. I believe that 5400 series is a lot of what Fort Hayes uses at this point. And then you have the big boys, which are the 7000s over there on the right. Those are like taking up a third of a rack on the really big guy over there. Right. So if you guys look at a rack back there, it's a big chunk of metal. But you'll notice all those blades and all the different options and everything else, full redundancy, et cetera. It's really what you're going to see in very large data centers. All right. Inside the systems or inside a firewall, we have what are called virtual systems. Don't confuse this with the virtualization stuff. This is just within the system itself. So with whether I have a physical firewall, a virtual firewall, it does not matter. We have what are called virtual systems. And what this allows us to do is take a physical device or a virtual one and split it into separate logical firewalls within the same one device. So think of this as I'm going to the mall down here in Hayes, right? I don't need to buy 4 or 5 or 6 or 10 of these little devices to protect all the different stores down there. I can actually put one big one in and actually create mini systems within that one that would count for every single one of those places inside. That way, traffic from, the shoe store doesn't affect the Chinese restaurant kind of thing, right? They're actually logically separate firewalls, but they can all be ran through one physical firewall. And so you have the ability to do what are called virtual systems. It creates an administrative boundary. The idea is to have multiple customers or departments within an organization where you want them to basically be on their own firewall and their own set of rules and policies. This can actually do that inside of there.
Quick question, Jason.
Yeah.
Do those have separate WAN ports, or are they all running off of one
you
static?
could designate that. So typically on these devices, they'll have like 14 ports across the front, and you can designate whether that's LAN, WAN, virtual wire, all sorts of stuff inside of it.
Oh, cool.
And so these VM50s that we're playing with, you guys will have access to, I believe it's 10 virtual NICs, and you can assign those as WAN ports, LAN ports, whatever you want when you go in through and configure it. And you guys will actually do that as part of the class. Good question.
Hey, I have a question, Jason.
Yeah.
So these virtual systems, so let's say if I have like 20 virtual systems running, can those all be managed through Panorama at the same time?
Yes, you could. I mean, but there again, these virtual systems are meant to be working on one physical firewall. And so that one physical firewall would be managed by Panorama as if you had multiple firewalls. Does that make sense?
I see, yeah. So that physical firewall would have its own Panorama then?
No, Panorama is really meant to manage multiple firewalls across there. And typically, you won't see that out in industry unless you have like 20, 30, 40 firewalls out there. Otherwise, most of the time, you just log into each one of those firewalls and manage them individually.
Okay. Makes sense.
So most, like, for example, most of the customers I deal with, they may have up to 10 firewalls. It's not worth the cost of Panorama to manage those. It's actually easier for us to log into each one and manage them individually. Same on the pfSense world, OpenSense world. They're just now getting to something like Panorama, but otherwise you're kind of individually managing those. The big deal is if you're in, you work for Kroger, for example, and you got all these different locations across the world, you would want to be able to have something like Panorama where you could overview all these different locations at once.
Yep, makes sense.
Okay, great questions.
I would assume Panorama would also give a lot of additional reporting options and
yes, yeah, you can do reporting. Gives you a lot more dashboards visualization. So if you're familiar with like a NOC or a SOC, that's typically where Panorama would be used the most as a way of monitoring and testing everything that's going across the. Yep. And RJ, is that the RJ I'm thinking of?
Yep.
Hey, bud. Good to see you.
You too.
All right. So VM series capacities. This is what you would see in here. So for example, it delivers the same capabilities as the physical firewalls, ensures the applications and data protection across clouds, etc. What you'll notice here is you'll see that the app or the firewall throughput with app ID enabled is going to be like 3 gigahertz at this first model, right? With 2 vCPUs, you have 4.5 to 5.5 gig of RAM. This is really what you're seeing here. You can push about 3 gig worth of throughput in there. If you want to start doing advanced threat protection, in which case we're actually going to be identifying every single packet that comes through there, notice how it cuts the throughput in half, right? So this is pretty common when you guys get into that. The firewall throughput, this is literally just, I want NAT, essentially with a little bit of policies and some app identification going on. I can get a pretty good throughput. But the moment I start wanting to do intrusion detection, intrusion prevention, which is what the advanced threat protection really is, you're going to cut your throughput in half. Now, if you have a 1 gig port, not really a big deal, right? I mean, you're way beyond the throughput of what you can physically do anyway. So to even get the 3 gig coming in there or a 1.5 gig, you're going to have a minimum of a 10 gig port in there, right? Because even a 2.5 gig port isn't going to get you the full throughput. A lot of what this really does, as they stair step through here and the amount of vCPUs required and the RAM required, really comes down to the number of new sessions per second. All right. So if I'm off browsing the internet, that's usually 1 session. But if I start opening multiple windows or everything else going through there, that may be opening multiple sessions through the firewall. So therefore, one person browsing the internet or doing their daily tasks may be creating hundreds of sessions going through there. What matters is the number of new ones per second, because once that session stays open, the firewall keeps it in its table until that session ends, and then it stops tracking that particular thing that's going through it. That really is what dictates what size you need as you go through on your network. So if you have hundreds and hundreds of users, you probably have to have capability of multiple to thousands of sessions going through it. Otherwise, like it shows here, the dedicated cores you would need going through there, the amount of RAM in both minimum is the latter number, so 4.5 gig minimum up to 5.5. And then the amount of disk drive capacity, this is usually to store all those log files and everything else going on the inside. Again, the CN series is really to provide visibility and security into containerized networks. It kind of interjects itself in between there, as you can kind of see. And that way you could block different things going in between. Natively integrates within the Kubernetes clusters, delivers the same thing as a PA and a VM. And the idea is to provide some layer 7 visibility and network application segmentation going through there. We won't cover a whole lot on the CN series. A lot of that is, you should know this part in terms of the written piece of this, but this is not something you guys are going to get technically hands-on with on the CN side. All right. So at this point in this module or this week, you should know those 3 pillars of the Palo Alto portfolio. You guys remember those? PA series, VM series, and the CN series, right? You have the being able to define the single pass architecture, which the idea with the single pass architecture is being able to come in from the networking down below and being able to work up through all the way up to the policy engine that's running through there on well. All right. So as that packet comes through on the network, we're inspecting it. We're going to send it through user ID, app ID, content ID in that order. And then it goes out to the policy engine to determine if it did not trigger on any one of these going before it. All right. Let's see. The pillars that we were talking about is really this stuff here.
Hey, Jason, I have a question here.
Yeah.
How does it map the user? Does it work with the integrates with the Active Directory or LDAP?
There's a couple different ways to do it, but yes, you could do both Active Directory. You can use a local database on the firewall itself. Typically, it integrates with Active Directory. That's the way I've done most setups. But on a smaller setup, there's no reason why you couldn't use the local database in there as well. And so what that'll do is when you log into the internet and try to access the internet, it pops up a portal, kind of like a captive portal at a hotel, very similar. You guys would log in with your credentials, and based off your credentials is where you can and can't go. So for example, if you're part of the HR group, it might allow you to go out to Facebook and all those other places because you have to do social media in order to do your job. But for Lance over there in computer systems, he doesn't get to go out to Facebook while he's, working during business hours. Kind of thing.
So where is that policy defined? Is it at the Palo Alto site or it's at the Active Directory level?
That policy is defined in the firewall. So what you would do is you would create users and groups, and then in the policy itself would either be defined as the user or as a group, meaning, depending on how you want to define your policy. And you guys, again, will do that in this class. You guys will actually create user ID filtering, and then you guys will be able to set up the policies that would block that kind of stuff. That's why I say when we get into the lab portion, it actually has internet access and everything else. So spend your time, obviously you'll do the lab, but don't be afraid to go off and do something completely different. It's a wide open environment as far as I'm concerned. Please don't go out and try to cause harm on the systems, obviously, but you do have I give people a lot of free reign in here on that so that you guys can actually put them through the test. And we'll even do that in our labs. We'll go, okay, that's great, but I want to block this. And so we would set up a new policy that allows us to block that. So we will go off script on Thursdays when I'm in here, just purely because I like showing you guys that it can do way more than what just the lab environment has. Great questions. Other than that, understanding the zero trust, and the zero trust is essentially we never allow anything to pass anywhere until we define it. So we never trust, and hey, she was listening. Always verify. All right. And then last but not least, being able to describe all the physical and virtual modules or models available from the Palo Alto networks. There is a nice little PDF document that you guys can get on the Palo Alto website, or I'm sorry, from the course here. Let's see here. And so I usually pull this one up as it's a nice little spec sheet of everything that can go through here. And so again, you're not going to get quizzed on this, but it's nice to be familiar with this kind of stuff. Yeah, why did that stop sharing up there? Of course. Stand by. There we go. Y'all see what I did there, right? Got to hit accept. Try this again. Okay. Pull up that PDF. So here it will kind of describe, especially on the physical ones, what kind of ports are available with the big 7080, capable of doing 687 gig worth of throughput, right? So it can handle a lot as it's trafficking through there. Most of the ones, like I said, that I've got to play hands-on with is back down to like this PA220. I got one of those I can show you. Again, it's a small little little guy. It's only 6 inches by 8 inches, about 2 inches high, little disc, about the size of my phone, roughly. And it even has an out-of-band, gig port that's on there, and you can do 1 gig through there. But you'll notice at the throughput that it's capped out at 560 meg. And the moment you start adding threat prevention in, you're going to be hit at about 300 there as well. You'll notice that you'll also get capped a little bit when you start doing IPsec throughput in there as well. So this A20, I believe, is another one that I have over there in the lab. We can show you that one. And then this VM50 is the one you guys will get access to. So you can deploy it at home or wherever you want. Just know you're going to be capped about 200 meg for a firewall throughput. And the threat prevention side of it is capped at about 100 meg. This is a pretty small little guy. Typically, that VM50 is used like out in the field at a remote hut or location, and you want that secure network coming back into yours and still being filtered out. So it's not something you would typically put in front of a small business or something like that. You would probably jump up to like a VM100 at that point, where you can do 2 gig of throughput or 1 gig of actual threat prevention. This is more like gas huts and things like that are out in the location. If they had a small little PC, remote fringe area, that kind of thing. Also great for us to do our training on. And on that side, I've used ones all the way up to like the VM50 side, where we have specific, used to be ESXi boxes, 2 of them. We would have a virtual instance on each one, and we could do HA, high availability, that kind of stuff. You guys will get to play a little bit with that as well. All right. Anybody have any other questions over this week's content?
So the interactive ones, like,
Yeah.
Is that just like another video?
Yeah, it's usually just a video or it depends. Sometimes they're like a drag and drop type thing. Like this one is just an IoT, and it's just going to have a series of videos. They've kind of updated this one here as well. So it doesn't hurt to come up with these. So the reason this is outside of what we normally have is these guys are constantly updating their content. So you could take this class this semester, and when I teach it again next spring, a lot of times this content is different because they constantly update it for what's going on that semester. So
There's nothing to like turn it on. It's just
yeah, there's nothing you have to do in there. It's just know that material before you go take this quiz. Yep. The big deal for this week, and that's just it. There's no lab, so we won't meet on Thursday. There's no lab this week. You guys will just have this quiz 1, and you guys can take that on your own. All right.
Hey, Jason, I have a quick question for you.
Yeah.
So what networking concept do you want us to brush up in order to do well on the lab?
You mean on the first lab coming up?
Overall, the entire course, what networking concepts we should go back and start reviewing them in order to do well?
Most of the concepts that you learned in like Internet Working 1. So the idea would be know your IP addressing, your subnetting, understanding VLANs, that kind of stuff. That is something that we'll cover in there. I can give you an idea of what the environment looks like here real quick, so you see what the topology is that you guys will be working with.
Okay.
So this will be the base topology that everybody will get access to, and you all have pods that you can work on. So initially, you'll have this as your VM50 device. All right. You're going to have ports assigned to upstream for the internet side or out to the outside zone. So this is indicating the zones that you guys will learn about here in a little bit. Then you have this firewall management port. This is the actual out-of-band management port that we talked about before. And this allows you to hit, devices out there. Now it's on the same subnet as your inside network as well, but it is a separate physical port on the outside. And then you'll notice here we have the 192.168. This will be classified as inside. We do have a DMZ zone. This is where we'll have a DMZ server out here that would do like FTP, web servers, that kind of stuff that typically goes in a DMZ zone. We have a danger zone that's out here on the V-wire, and we'll talk about what a V-wire is and such. And then you get to this outside. At that point, it hits a little V router out here. And this is just mimicking, a connection out to a ISP at some point. And then from there, it's actually got internet going outbound. So when you guys first load up the lab environment, we talk about that next Thursday. The base configuration in there will actually have internet access and all that configured. When you start lab 1, nothing's configured, right? There's no internet access, nothing. You actually have to go through and manually configure these interfaces, and then we'll work our way up through getting internet access on there. So there's quite a bit more steps than you would have on like a home firewall, because you would not only just configure your WAN interface and your LAN interface, but then you actually have to go set up the NAT policies and how you're going to do that. You have to set up the security policy that actually allows the traffic to go through those two networks. All of that has to take place in order for internet to actually go outbound. And we'll cover this in pretty good detail going through. That's really the gist of what you'll need to know in this lab environment, is just being able to, know your subnetting, know your ports, your common ports. So like when I was quizzing you over 22 and 80 and 443 is
HTTPS,
right. And so 23.
SFTP.
Yep. SFTP on 23, or 23 is FTP, right? And then you could do SSH over that. I'm trying to think of what other services you guys will be playing with. There'll be other ones you guys should, know just based on networking. So 5,000.
No.
3389.
That's remote desktop.
Remote desktop for Windows. Good. Go back through and kind of just look over ports. You could just do a Google search at known, the generic ports, and that's pretty much the ones that go there. Again, you don't have to memorize it, but you're in the field for 20 years. You tend to memorize this. It just goes through, right? And the beauty of doing that kind of stuff is, again, especially in the next generation firewall, is just because I'm on port 3389 does not mean that I'm getting RDP traffic over that. I could literally be getting anything over it. And that's how we beat firewalls. So in the cybersecurity realm, if I'm firewalking, which is me going against a firewall, testing every port to see, can I traffic something other than port 80 over, or can I traffic something other than web over port 80? And if I can, that's how I can break into systems and do that, right? Because most firewalls are going to allow things like port 80 through. Otherwise, their users would never get on the internet, right? And obviously they have to allow 443, but what we really want to know is, are they actually doing the things over those two ports that they say they're doing? And if you guys have played with BitTorrent and that kind of stuff, you've known you've had to force it to go through different ways to beat firewall rules, whether it's the school or the business or your home or whatever. I'm kidding. Nobody's ever done that, right?
Never.
Never, right? Okay. So yeah, knowing the services, that kind of stuff, just as general rule of thumb. Again, you don't have to be memorized. We'll cover all that when we go through here. Great questions, though. I appreciate the back and forth. That actually makes this semester go a whole lot smoother when people ask questions. Otherwise, I can't tell if you're lost or you just don't have questions. So please engage. That's more than useful. All right, I'm going to stop the recording.